just kind of join in, and then Dr. Massar, our moderator, will take this away.
Good afternoon, everyone, and thank you for joining us in today's webinar. This webinar is hosted by the Center for Sustainable Energy and Environmental Engineering at East Carolina University. The mission of the center is to promote, enhance, and serve some of the things that we do at the center is on-site energy, P2 and lean assessment, regional and on-site P2 energy training, regional workshops, technical and engineering support, cash flow and market analysis, return on investment. My name is Carol Maserra. I am an assistant professor at the Department of Construction Management at ECU. I am also the director of the Coastal Resilience at the center. Our speaker today is Dr. Katy Wolf. Dr. Wolf is a consultant on solvent alternatives. She was previously the director of the Institute for Research and Technical Assistance, IRTA, which is a non-profit organization established in 1989. IRTA's work involved finding safer low VOC, low toxicity alternative. IRTA also performed emerging and advanced technology demonstration. IRTA's work focused heavily on solvent alternative in cleaning, drying, cleaning, electronics, paints, and coating. Dr. Wolf spent 14 years at the Rand Corporation doing research. She has authored more than 200 publications. Dr. Wolf has a PhD in chemical physics. Before starting the presentation, let me share some housekeeping with you. The webinar is recorded. Please make sure that your microphone is muted during the presentation. First part of the webinar is presentation. Then once we are done, we will open it for a Q&A session. Any question before we get started? Okay, thank you again for joining us, and I will turn it over to you, Dr. Wolf.
Hi, everyone. I'd like to start out by thanking the Center for inviting me, and particularly Grace Jacobson, who has been very helpful. And today I'm going to talk about case studies of safer alternatives to vapor degreasing solvents. There are many different types of operations that rely on vapor degreasing. It's an extremely effective and forgiving process, and it's been used extensively since World War II. And the types of operations that employ vapor degreasing, they're very widespread, and they include metals processing, electronics, and aerospace. And the solvents most commonly used historically in vapor degreasing operations include the four I've listed on this slide. And they include the three chlorinated solvents, trichloroethylene or TCE, perchloroethylene or PERC, and methylene chloride or MC. And they also include N-propyl bromide or NPB, which is a brominated solvent. And the safer alternatives I'm going to discuss today are appropriate for applications using any of the solvents. The four halogenated solvents have a whole range of health and environmental problems. In terms of health effects, they're all carcinogens, and some of them also cause nerve damage and reproductive and developmental problems. Methylene chloride in particular has caused deaths from acute exposure to it. In fact, because of the numerous deaths it's caused, EPA ended up banning the use of methylene chloride in consumer product paint strippers a couple of years ago. That was where most of the deaths were occurring. from exposure to these consumer product paint strippers. And for many years, PERC and TCE have leaked from operations or been improperly disposed of, and they've caused contamination of soil and groundwater in many parts of the country. Some states and local districts have restricted the use of the solvents, and EPA, under the Toxic Substances Control Act, or TSCA, is currently regulating the 4 solvents for potential nationwide regulation. And EPA's findings so far under TSCA indicate that all 4 of the solvents pose an unacceptable risk in virtually all of their applications, including vapor degreasing. So the solvents are likely to be more stringently regulated or banned across the country in the future. Now, some of you may not be familiar with the vapor degreasing process, and I'm just going to describe it briefly in simple terms. And for the people who are familiar with vapor degreasing, just bear with me while I do this. A vapor degreaser is a stainless steel tank with a heater in the bottom and a set of cooling coils around the top perimeter. You place liquid solvent in the vapor degreaser and you heat it to its boiling point. And this establishes a vapor zone of solvent above the liquid zone. And the cooling coils around the top condense the solvent vapors back into the vapor zone, and they essentially hold the solvent in the vapor degreaser, although they don't do too good of a job since there are, of course, emissions that do occur. Now, the way vapor degreasing works is that you place the dirty parts into the vapor zone of the degreaser, either in baskets or on fixtures. And when you put those cold parts into the warm solvent vapors in the vapor zone, it causes those vapors to condense onto the parts, and that cleans them. The dirty solvent liquid falls into the liquid zone of the degreaser so that the vapor zone is always composed of clean solvent. Now, this definition is very simplistic for the basic degreasing process, and many systems and processes have additional features and are much more complex. But the degreaser I showed you on the previous slide, it's an open top degreaser, and the solvents used in those systems must not have flash points. Flash points for solvents are lower than boiling points. So if you heat the solvent to its boiling point, it will encounter the flash point first. And if there is a source of ignition present, the solvent could either ignite or explode in the vapor degreaser, and that would obviously be very dangerous. So the 4 halogenated solvents that I'm discussing here, they don't have flash points, so they don't pose that problem. Now, near the end of the presentation, I'm going to return to this point, which is why I brought it up. Now, turning to the case studies, I worked with 8 different companies in 3 projects for the case studies I'll discuss today. There were 4 companies in a project I worked on with the nonprofit organization called the Pollution Prevention Resource Center, or PPRC, in the Seattle area. That project was sponsored by EPA under the Pollution Prevention Program under a grant. And I also worked with 2 companies in a project sponsored by the Hazard Evaluation System and Information Service, or HESIS, which is part of the California Department of Public Health. And in all 6 of the cases, the companies were using N-propyl bromide. That really isn't very surprising, since many regulatory agencies and pollution prevention providers have recommended that companies switch away from the 3 chlorinated solvents to N-propyl bromide in the last decade or so. And that follows from the fact that N-propyl bromide wasn't designated to be a carcinogen until quite a bit later than the chlorinated solvents were. So many companies did move into that solvent. Now, I'll also discuss 2 case studies of companies I worked with in Southern California at an earlier time period. And these 2 companies used trichloroethylene. 5 of the total of 8 companies I worked with ended up converting to the alternatives. And I completed work with the other 3 companies, but they didn't make the conversion within the project timeframe. And as you'll see as I go on, I tried to select the case studies to represent a wide range of different types of operations that rely on vapor degreasing. The first case study I'll talk about is a company called MAPSCO in the Seattle area. MAPSCO offers non-destructive testing services to aerospace companies. The type of non-destructive testing the company performs is called magnetic particle inspection. And in magnetic particle inspection, you use a fluid that contains magnetic particles and you magnetize it. You place the part that you want to look at in the fluid, and if there's a flaw or crack in it, the magnetic particles will line up next to it so you can identify where it is and you can repair the part rather than discarding it. Now, historically, the company used a large N-propyl bromide vapor degreaser for cleaning the parts. We tested the company's parts with a water cleaner supplier, a company called Brulin, and we identified a suitable cleaner that the company was already using in other parts of their facility. The parts were cleaned effectively in the Brulin lab in an immersion agitation system, and accordingly, I sent in an equipment supplier to quote the cost of this type of system for MAPSCO, but MAPSCO felt the cost was too high. So MAPSCO did find a secondhand system, but it was purchased by another company before they could buy it. So then I got in gear and I found another place that was offering a secondhand system of the type that was originally quoted, and MAPSCO ended up buying it, and they've been using it for a year and a half, 2 years, something like that, for quite some time now, successfully. Now this slide shows a picture of the non-destructive testing stand up in the left-hand corner, and the vapor degreaser shown in the picture on the right. The bottom picture shows the water cleaning system the company ended up purchasing. It has a wash, a rinse, and a dry section. And as you may be able to see from the picture, I hope you can see this, it also has an automated system for indexing the baskets from one bath to the next. Now this slide shows the annualized cost comparison for MAPSCO. I generally use an annualized cost for comparing the cost of using the vapor degreaser on the one hand and the cost of using the water-based cleaning system on the other hand, because it's straightforward and easy to understand. In general, I also don't include the cost of the vapor degreaser in the analysis because in nearly all cases, the degreasers were purchased years ago, sometimes decades ago, and they've been paid off by now. I'm not going to be able to discuss the assumptions I made to do the cost analysis in comparison for MAPSCO or for the other case study companies I'm going to discuss today because of time constraints. I wanted to give you more a flavor of a number of facilities, so I didn't want to take a lot of time describing how I got the numbers. I do discuss 4 of the case studies in much more detail where you can get this information in the PPRC document I referenced earlier. And as you can see, perhaps from the total cost figures of this on this slide, MAPSCO reduced their cost of cleaning by 26% by converting to the water cleaning system. The second company I'm going to discuss is called Exotic Metals Forming, and they're in the Seattle area as well. And they make ducting of all kinds for aerospace and industrial applications. And the company used a large N-propyl bromide degreaser for many years. Now, Exotic is subject to a lot of aerospace requirements, and they're also subject to the European Union REACH requirements, and those can be very stringent, and sometimes they're different from the aerospace requirements. So you have to be careful. We didn't want to have them convert to something that was restricted under the EU REACH regulations. So we did testing with a water cleaner supplier, and we did identify a good alternative. And the company ended up converting to that cleaner for this operation and for most of their other water cleaning operations that they had in the facility. The company was able to use one of their existing immersion agitation systems for cleaning the parts that had gone through the vapor degreaser previously. So they didn't even have to purchase a new cleaning system, which gave them a lot of savings. And we also worked on a related process with Exotic using an anti-spatter product in a laser cutting operation. Over the years, I've worked with many, many different facilities, and I often would work on other processes when I started on a cleaning process with them. Other related processes, or sometimes unrelated, that also use solvents. So on the top left of this slide, the picture shows one of the company's parts. And as you see, they're very complex. The picture on the right shows the vapor degreaser Exotic used. The bottom picture shows a fixture a company engineer designed for testing the anti-spatter alternatives. This slide, the picture here on the left, shows the immersion agitation system water cleaning bath and the 2 rinse baths that follow it. The picture on the right shows a temporary pressure washer rinsing station the company used, and they have to use that after the other 2 rinses. They have to really rinse these parts in order to get them cleaned. Exotic planned to purchase a better pressure washer station in the future, and I'm sure they've done that by now. This slide shows the annualized cost comparison for the cleaning operation. Again, I'm not going to describe how I determined the numbers. You can get that in the reference that I gave you earlier to the PPRC report. But the total figures in the table show that the company reduced their cost of cleaning by 81% through the conversion. Now that is really a substantial reduction, and that's because they didn't have to buy a new cleaning system. They could use one of their existing systems. So this slide shows the cost comparison for using the N-propyl bromide anti-spatter that they were using and an alternative water-based anti-spatter they ended up adopting. Now, we had tested a number of commercially available water anti-spatter products, but none performed exceptionally well. One of them did perform reasonably well, but it contained a surfactant that was an endocrine disruptor. And these types of surfactants are regulated under the EU REACH regulations, but they're not regulated in this country yet. So I decided to approach the supplier, and I spoke with the manager and asked if the company would be willing to reformulate the product. And I even told him what family of surfactants he could use instead. But after weighing this, he decided that the company didn't want to change the formulation. And this was probably quite short-sighted, since it's likely that endocrine disrupting surfactants will probably be regulated in the US in the not too distant future as well. So I then approached Brulin, the company that was supplying the new water cleaner, and I asked them if they would try to formulate a water-based anti-spatter. And they decided to accept that challenge, even though they didn't right then carry any products of that type at all. But they were able to make a water-based anti-spatter, and they also conducted all the testing necessary for satisfying the aerospace requirements for the company to use that. And the anti-spatter product they developed performs really well, and it's very cost-effective. Now, there are literally thousands of companies in the US that use solvent-based anti-spatter products. It's primarily based on methylene chloride, although this one was based on N-propyl bromide. They use them either in laser cutting, but also in welding. And, you know, there are millions of welding operations. And this water-based product would be a good alternative to the solvent-borne ones that people are mostly using. So Exotic did convert to that product, and it ended up reducing the cost for the anti-spatter by 71%, which again is a substantial savings. On the PPRC project, I also worked with a plating company, and this company, a job shop, they used an N-propyl bromide vapor degreaser for cleaning polishing compounds from parts made of a whole variety of substrates, which I'm showing you on this slide. Now, I knew from my past experience that polishing compounds are difficult to remove. And I knew we would need an aggressive water cleaner, but more important, I knew we'd need an ultrasonic cleaning system for cleaning the parts. Ultrasonic systems are very aggressive. We did testing with a water cleaner supplier and found a suitable cleaner. I arranged for 2 equipment suppliers to provide quotes for ultrasonic systems, and the company at the time considered them, but they didn't make the conversion in the time frame of the project. This slide shows the variety of parts the company has to clean on the left. And as you see, they're made of a lot of different substrates. They have steel, stainless steel, brass, and copper parts. On the right, the picture shows the inside of the vapor degreaser, which in this case, it's really deep and it has to be lowered into the floor of the facility. The picture on the bottom shows the ultrasonic system I used to do the cost comparison. Slide shows the cost comparison. Again, I'm not going to go into the derivation of the figures, but note that the total values show that the company would reduce their cost by 39% if they made a conversion to the water cleaner. The last company I worked with on the PPRC project was a tube manufacturer who made small diameter tubes that are used to transfer liquids and gases from one place to another in aircraft. And the company had a really old vapor degreaser when I started working with them. I probably hadn't seen one like that for 35 years. And they actually had not paid attention to it, but they had to when I started working with them, and they ended up converting to a new, tighter vapor degreaser shortly after I began work. Now, again, we found an appropriate water cleaner. And another similar company in Southern California that I knew about, they had converted to an ultrasonic immersion system some years ago. But the equipment supplier I was working with and I thought we could use a different operation that would be less costly. Ultrasonic cleaning systems are quite expensive, relatively speaking. We did testing in a spray cabinet with a specially designed fixture to flush the insides of the tubes, and it ended up working successfully. The equipment supplier quoted both an ultrasonic system and a spray cabinet, and as expected, the cost of the spray cabinet was the lower of the two quotes. The plating company evaluated the quotes, but again, they didn't convert within the time frame of the project. This slide shows pictures of some of the different types of tubes the company makes. The top left-hand picture shows some very small diameter tubes, and the bottom left picture shows some tubes that have much larger diameters, so that the parts they need to clean vary in their internal diameter. The bottom right-hand picture shows the spray cabinet that was used for testing. And I don't know if you can see this, but there's a tube clamped in the system we had used for testing. Again, I'm not going to go into the derivation of the cost for the tube manufacturer, but you'll note in this case, the cost of converting to the water cleaning system is actually higher than the cost of continuing to use the vapor degreaser. Now, I think the explanation for that is that they bought a new, tighter vapor degreaser right after I started working with them. So it was much less emissive and used less solvent. And I think if I had included the cost of that equipment in the cost comparison, perhaps the water cleaning system would have looked better. But I didn't include it, just to be conservative. Let's see. Oh, in the HESIS project, moving on to it, I worked with two companies in Northern California, and one was a microelectronics manufacturer. The microelectronics that they made were used in medical devices, so the company was subject to Food and Drug Administration, FDA requirements. And they were using a thick film deposition process to lay down layers in their manufacturing, and they needed to remove particles and handling soils several times during the thick film process. And they'd used an N-propyl bromide vapor degreaser for many years for cleaning the parts from this process. Now, partway through the project, I learned they had a water cleaning process for removing flux from printed circuit boards. And although the cleaner they were using for that process wasn't necessarily an ideal cleaner for the thick film deposition parts, I thought it would be worthwhile to try using it in case they wouldn't have to convert to an alternative cleaner. So we did the testing, and the defluxing cleaner actually worked well. I then provided the company with information on the problems with N-propyl bromide, And they gave the FDA that information and also the quality control information from the cleaning tests we had done with the defluxing cleaner. And the FDA approved the company to use the defluxing cleaner. And I have to admit that was very quick approval. In some cases I've known about historically where I worked with companies, it can take up to 7 years to get that approval to change the process. The FDA is very reluctant to do that. The company converted and they didn't need to purchase a new cleaning system or even a different cleaner. And they obviously reduced their costs significantly through the conversion, but unfortunately they wouldn't provide us with the information needed to do the cost analysis. Now this picture on the left shows some of the microelectronics devices the company makes. And the picture on the right shows the vapor degreaser the company was using. The second company in the HESIS project I'll discuss, it's a job shop that makes optical components. The company uses materials like pitch and wax to polish the components, and those types of contaminants are extremely difficult to remove. They'd been using an N-propyl bromide vapor degreaser for several years. And I'd worked with some companies in years past in Southern California, and I had assisted them in converting to a soy-based cleaner, which turns out to be very good at removing things like pitch and wax, which were the contaminants we needed to remove. I asked an ultrasonic system manufacturer, I knew we'd need ultrasonics too, because you need an aggressive cleaning system. I asked a manufacturer to test the company's parts, and the soy cleaner followed by a water cleaner. You need to follow it by a water cleaner to rinse off the soy or it'll leave a residue. That ended up cleaning the parts effectively. And I then arranged for 2 equipment suppliers to quote systems, and the company evaluated the quotes, but again, didn't make the conversion. I did the cost comparison though, based on the company purchasing the system with the larger baths. And I reasoned that they wouldn't need to be changed out as often, and that could save on labor costs. The picture on the top left of this slide shows the pitch. You can see it there, it's black. It's an asphalt-like material that the company has to clean. The picture on the right shows the N-propyl bromide vapor degreaser. And the bottom picture shows one of the components the company makes. Comparison in this case shows the company would be able to reduce their cost of cleaning by 4% if they were to convert to the soy-based cleaning alternative. Now, the 7th case study is a company that manufactures and takes older valves in from the field and refurbishes them. The valves they process are made of many different substrates, and they're used in various applications. One valve they were processing, for example, was used to hold flour in a food processing facility. And as you see, I've indicated on the slide that they had a lot of caked on types of material when these valves come in. Now, when they come into the plant, they're contaminated with a lot of different substances, and you need to get those off. So they need to be cleaned before they can go on to further processing. So the company had used a 35-gallon trichloroethylene vapor degreaser for many years, and they did end up converting to a water-based cleaning system. We had tested the parts with a water cleaner supplier and found an appropriate cleaner. The system the company purchased was a large spray cabinet, which I'm showing there. And as you may be able to see, you have a turntable down here in the bottom, and you place the part cleaned on that turntable. And then you have a spray bar, as you see here. This is a spray cabinet, so the cleaner is sprayed onto the parts. And that spray bar can be adjusted up and down depending on the size of the parts. It can accommodate parts of a whole range of different sizes. And the spray pressure in a cabinet like this can be as high as 100 pounds per square inch. This slide shows the cost comparison for the conversion. And again, I'm not going to go into the details of the assumptions I used, but I will note that I updated the costs here. So they're somewhat different from the costs in the reference I showed you earlier for these 2 facilities, this facility and the next one I'm going to describe. that I showed you on the earlier slide. And the figures in this case show that the company reduced their cost of cleaning by 18% by converting from the vapor degreaser to the water cleaning system. Now, the last case study is a company that manufactures nameplates. The vast majority of the nameplates are made of aluminum, probably nearly 90%, but they also do make some out of stainless steel and brass. And the metal stock arrives at the facility with a protective oil coating, which has to be removed before processing. And the company was cleaning about 1,000 pre-cut nameplates per day in a 50-gallon vapor degreaser. And that's an extremely heavy workload. So again, we conducted testing with a water cleaner supplier and found a cleaner that was effective. Because of the high workload, though, we thought the company should test a conveyorized rather than a batch cleaning system so they could save on throughput and labor. And the testing indicated that this was a good decision for the company. The company did purchase a conveyorized system for use with the water cleaner. And I'm showing the system here on this slide, and you place the nameplates on the conveyor belt at the entrance of the system. And it has a wash section, a rinse section, and a dry section. And you spray the cleaner on and you spray the rinse water on, and the water cleaner is delivered at about 100 pounds per square inch pressure for cleaning the nameplates. And the nameplates are then rinsed with deionized water in the second section, and then they go through a hot air dry section at the end, and they emerge from the other end of the system on the conveyor. Now, this slide shows the cost comparison for using the vapor degreaser in the water cleaning system. And as you may be able to see, there's an extra line in this cost analysis for deionized water. I didn't have this line in the other cost comparisons. In the Los Angeles area where this company is located, the tap water quality is very poor. In many cases where companies need spot-free parts, they have to use deionized water for the rinse. Otherwise, it'll leave a residue. This turns out not to be the case in Washington and Oregon, where 4 of the other case studies I worked with are located. In those cases, the tap water quality was good enough to deliver spot-free parts. So I wanted to bring this up because you just have to be aware that the water quality may vary in different parts of the country. And in some cases, they may have to use deionized water for rinsing. So the total cost figures for this facility show that the company reduced their cost of cleaning by 22%. Through the conversion. And a large part of the savings was the lower labor costs they ended up with from automating the system by choosing the conveyorized equipment. This slide shows some of the issues that arise when you work with companies on alternatives. Companies often start out wanting a drop-in alternative, but there really aren't any that don't pose health and environmental problems of their own. I could actually give a whole nother presentation on what the potential alternatives are and what their advantages and disadvantages are, and you would see that there isn't any magic answer. If the company has always used vapor degreasing, they'll often be skeptical that water cleaners will work. And I find the testing with water cleaner suppliers and water equipment suppliers can dispel those fears. You clean their parts and you essentially prove it's going to work. You send the clean parts back to the facility and they can put them through the next process steps. And when that's successful, you've essentially proven they can use water cleaners. Now, the suppliers generally will do all the testing for companies for free because they want their business. The suppliers will often also do the testing to get suitable cleaners aerospace approved. But there are many cleaners that already do have aerospace approval. I talked about how that one company on the anti-spatter operation, the water cleaner supplier who also made the water anti-spatter, did all the testing to prove that it would pass the aerospace standards. So another issue is cost. I try to make the alternative cleaning systems as low cost as possible. No one wants to pay more than they have to for cleaning, which is usually considered by facilities to be an ancillary process, not very important. In one case here, one of the companies bought a secondhand system, as I mentioned, that was MAPSCO. And in another case, we tested the spray cabinet, which was cheaper than the ultrasonic system for the tube manufacturer. Finally, when I worked in Southern California, where they have a robust regulatory regime, companies were more open to converting. In other locations, there are few, if any, regulations, and I found there's little incentive to convert, even when you can show companies that it's cost effective to do so. The barrier to change is just very high. It's also worth noting here that I haven't included certain costs for continuing to use the vapor degreasing solvents in my cost comparisons. And these would be things like health problems the workers might experience or days they might take off because they've been exposed to the toxic chemicals. And if you included those costs, it would certainly raise the cost of continuing to use the vapor degreasing process. Just to conclude then, water-based cleaners are viable alternatives and they're appropriate for the vast majority of companies using vapor degreasing today. And other safer alternatives like soy cleaning, for instance, they're suitable in certain cases. And again, there is never going to be a magic answer, and you actually have to know a lot to guide companies properly, so they won't be heavily influenced by certain vendors who want to sell them inappropriate or unsafe alternatives. You have to be able to counter their claims. As an example, I mentioned earlier that solvents used in vapor degreasers shouldn't have flash points. Some suppliers are telling users they can use a solvent they have as an alternative in their degreaser. And in some cases, the solvent has a flash point, so companies have to be very careful about that. You don't want the degreaser to blow up your facility. Finally, there's been a lot of switching from one solvent to another as each solvent has been increasingly regulated over the years. And I mentioned that N-propyl bromide was not found to be a carcinogen until years later. And so a lot of people switched to it, which was not a good option. Now, really the best option for companies is to find a permanent solution so they don't have to go along with this shell game of switching from chemical to chemical anymore. So here's my contact information. Please feel free to call or email me if you have questions about a solvent operation of any kind. It can be any kind of operation where solvents are used. I've worked on many different types of solvent operations, and I might be able to provide you guidance depending on what it is. And now I'll be glad to take any questions you have or listen to comments you may want to make. And I thank you for your attention.
Thank you, Dr. Wolf. Any questions from the audience? We have a question in the chat. Have you seen that alternatives non-chlorinated solvent with flash points have PFAS superiors? So if you are not asking a question, please mute yourself.
I'm sorry, I didn't get what that acronym was.
I don't know. So Jill, can you explain what that is?
Yeah, it's a P. Can you hear me?
Yes, we can.
It's PFAS, so the perfluorinated.
Oh, PFAS, yes.
Yeah.
Okay. I'm sorry, I thought it was PSAS. Okay, you can use solvents with flash points in a cold cleaning operation, certainly. It's just not usually as aggressive as vapor degreasing, and it might not be suitable for your different type of operation. Now, there is an indication, I've been looking into this recently, that the EU is going to restrict some of the alternatives that are available. These would be halogenated solvents of various kinds, the hydrofluoroolefins and the hydrofluoroethers that have been available for several years. And they may be moving forward to designate those as PFAS compounds. So that could be a problem in the future. I don't think EPA is looking at those options as being PFAS right now, but they may in the future if the EU does come forward and do that. I don't know if that answers the question. You can use the solvents with flash points in cold cleaning operations where you don't heat them to their boiling point. You just may heat them a little or not at all. And they might be effective for an operation, but they might not. It depends on the operation. It's very operation specific.
Yeah, thank you, Katie.
We have another question from David. Would there be any disposable waste management cost associated with the treating the wastewater of these water-based systems, even if they are closed-looped? Usually the tanks are dumped, recharged with some frequency.
That's right. I didn't go into that in the cost because I would have if I had talked about how I derived those numbers. But for example, with the company MAPSCO that I talked about, they had a wastewater treatment system in their facility. And generally, people who have wastewater treatment facilities treat something like 25,000 gallons a day. And they were able to go, I can't remember exactly now. I'd have to look this up. You can look it up in the source I gave you, but it was something like they were needing to dump their wash bath once a month. And it was 100-gallon bath, if I remember correctly. And so 100 gallons into 25,000 gallons per day for their wastewater treatment was nothing. And I mean, keep in mind that you also, households process about 100 gallons a day. So their need to dump was 100 gallons a month, which was maybe 1/30th of a household. So it's actually very small. You keep using the water-based cleaner and you add cleaner concentrate to it periodically, and it can last you quite a long time as long as you have good removal technology. And then as far as wastewater is concerned, you can close loop it. You still do need to dump it periodically, but again, 100 gallons is not that much. Now, companies that don't have wastewater treatment facilities can ship their waste off-site, but it isn't very expensive to ship 100 gallons a month off-site or every 3 months or whatever it's going to be that you need to dump the bath. And it can be disposed of as water waste generally, which is a lot cheaper to dispose of than RCRA hazardous waste. So I hope that answers the question.
Another question, you mentioned that you could have included health costs or sick day cost in your cost comparison, but did not. Could you talk about why you decided not to include those costs? Did you ever talk about those costs with companies?
Yes, and in some cases, I did put the cost of PPE, personal protective equipment, in there, but I didn't do the health costs. It's very controversial, as you know, to include those things. People would dispute the numbers, and I don't know how I would calculate them particularly. I mean, economists are better at doing that. The other thing is that I want to be as conservative as possible and still demonstrate that you can get a savings from converting. So I don't include costs like that someone may dispute and say, you know, trichloroethylene doesn't cause cancer. So you can't include that. I'd rather just be conservative and show that I can accomplish a savings without including costs like that.
Okay, thank you. Another question from Paul. Do you find any relationship between company size and willingness to adopt new technology? It would seem that cost saving in the thousands to tens of thousands of dollars would be more appealing to smaller operations. Is that what you have found?
Well, actually, it's kind of interesting. I think it would be the reverse. I think smaller companies are more reluctant to convert in certain cases. I mean, of course, some of them are very progressive, and so they want to adopt alternatives. And I have encountered companies like that. But smaller companies, like the optical component manufacturer that I worked with, there was a single owner, and he was a very small company, and he was afraid to convert. Even though they might see that they could save money, they're worried about converting and jeopardizing their processes. So I think smaller companies are more that way than larger companies. But I mean, in Southern California, I had a lot. I mean, nearly every company I worked with over decades ended up converting. And it's because they have a stringent regulatory regime. I mean, it isn't enough just to show people cost savings, because they can say, well, I won't really save any money if something goes wrong with it. And so the way to get people to really be resolved to convert is to have a regulation. I'm a big fan of regulations.
Any other questions? Okay, no more questions. Thank you so much, Dr. Wolf.
I hope everyone enjoyed it. And if you'd like to contact me, please do.
Sure.
Thank you.
Thank you all.
Thank you.
Thank you. This was really interesting. Thank you so much.